Hi, this is Kevin Trainer, and I'd like to welcome you to my tutorial on resolving many-to-many relationships as a step within logical database design. So this is one of a series of tutorials on logical database design. And as you can see from the graphic that's up on your screen right now, we're most of the way done. We're at the fourth of 5 major steps. So the last major step that we did was to normalize the design, and that had lots of sub-steps. And now we're on resolved many-to-many relationships. Relational databases cannot represent many-to-many relationships directly. It is both, well, it's sort of a two-sided coin. On one hand, there are other technologies that can represent them more directly. On the other hand, relational databases has a way to represent them. It's really very elegant and efficient, and it's really part of the simplicity and the elegance of the overall relational model that we handle many-to-many relationships the way we do. Okay, so I don't want to paint relational databases as somehow deficient because they can't represent these directly. You could consider it as part of their elegance and charm. Okay, so let's look at a couple of many-to-many relationships in our design. And since the last time you've seen the design, I've made a couple of improvements. I dragged a couple of the tables around, and I used a little more space, and a couple of places where I didn't have the data type on the column, I added that. So, so far we have one many-to-many relationship already implemented, and that is the relationship between use case and system user. And we did that because we're kind of working on a prior step in the method, and that was to eliminate repeating columns. And I just want to say is that a lot of the changes that you make within a database could probably qualify for more than one of the steps that I put on the chart. Okay, so in this case, we needed to create a many-to-many relationship between system user and use case, and we created the associative table, or intersection table as some people call them, to resolve the many-to-many. And as you can see, what had been a many-to-many, or what would have been a many-to-many between system user and use case, is now 2 one-to-manys. The many side is up against the associative table permission, and the one sides are in system user and use case. And then we've got a way to implement all the relationships that we're showing in the diagram. Okay, now let's take a look at 2 other many-to-manys that we have that are unresolved. One is registered for. So each student is registered for 0-to-many course offerings, and each course offering has 0-to-many students. So this can't be implemented directly. We need to add an associative table. So let's just go ahead and do that. So we're going to take away this registered for table. Okay, we're going to delete that relationship, not table, but relationship. And now we're going to pull a table symbol out. Okay. And again, these associative entities, they either get a funny name that comes from the combination of the two primary entities, or they get a custom name if there's a name that makes sense in terms of the application. So just to show you how you would create a funny name, you would call it something like this: course offering student. And then those of us who are part of the club that knows that this is the way you name associative tables or associative entities would say, oh, that's the associative entity between course offering and student. Well, it turns out that we can think of a name to represent what this entity or table is, and it's a registration. It's a registration for a course offering. So we're going to double click on that and just call this registration. All right. And how do we make the keys work in these associative tables? Well, it's a combination of the two primary keys. Okay, so student ID is one of the primary keys. The other primary key is 3 columns long: semester ID, course number, and section ID. So registration is going to have a primary key made up of 4 attributes. So let's, first of all, let's get rid of the data. We could keep some data here. We could keep the date or the time when the registration happened, but we're not going to do it. We don't have a specific requirement for that. Okay, so the first one is going to be student ID. Okay, and then we're going to insert 3 primary key fields, or columns, I guess. Okay, so we've got 3 here. So student ID, semester ID, course number, and section ID. So those are the columns that make up the key of this associative table, the primary key. And of course, we need to pull out relationships. And where is the many side going to be? Well, it's going to be up against this associative entity or associative table. So let's pull out a relationship. Let's put the many side on registration, and then let's pull the one side over to student. Doesn't seem to be behaving. So let's give it another try. There it is. Okay. And let's pull out another one. And again, put the many side in registration. And then pull the one side over to course offering. And we got that working. Okay. So that's it. Again, this is a table that's all key. Okay. And it's really only there to make the plumbing work. It's there to resolve the problem that we have in implementing a many-to-many relationship between student and course offering more directly. Now, as of yet, we haven't put in the IDs. I'm sorry, the data types. So let's add in the data types. And we lost the connection there. Well, geez, that wasn't what we wanted, was it? So let's try that again. All right. Sometimes this Visio diagrammer leaves a little bit to be desired. Okay, so student ID, semester ID, and course number are all ints. And section ID is a varchar. So let's just put a varchar there. Oh, I'm sorry, and course number appears to be a varchar as well. Okay, so we're going to have that. Okay, so we have resolved one of the two many-to-manys that we have. The other one that we have is between student and class meeting. Okay, and this, we have one student can attend many class meetings, and each class meeting can be attended by many students. So we have a classic many-to-many. What we're going to do here is we're going to try to make enough room to put this over here. And let's try to move stuff just a little bit to the right. Sometimes I don't know why these things will not cooperate, but they won't. And you have to ask yourself why. Okay, so there is a relationship between class meeting and student. It's called attended. And we're going to have to replace that with a table, an associative table, an intersection table. Okay, so let's highlight the relationship. Sometimes when they're so big, it's hard to see that they're highlighted, and delete it. Okay. And then let's pull out a table. Okay, and I almost have enough room for this, but I'm gonna put this over on its own little sheet here. Not because this is great artwork, but because I want the diagram to work. And I'll leave it for further cleanup to make things work the right way. So this is an entity between student and class meeting, and we could call it attendance. I kind of like it attendance. Okay, so attendance. Okay, all right. Now this is probably going to have a pretty big key, because again, what's the primary key of attendance? Well, it's the combination of the primary keys of student, which is student ID, and class meeting, which of course is the 4 columns here. So we're going to have a 5-column key. So let's add 4. Add 1. Add 2. Add 3. Didn't quite get what I wanted there. And add 4. And again, we're not going to keep any data. Could we keep some data? Yeah, we could, but we haven't really been given a requirement that we need to carry any data. The only requirement that we have for this is that we need to make a many-to-many work. Okay, now we just have to pull the relationships out. So the many side goes up against the associative table or intersection table. So let's pull this and put the many side on that table. And then let's put the one side over here. And that's got the one-to-many going the right way. And now we need to connect attendance and student. Now, student is a long way away from attendance, and it's kind of a little bit hidden. So we're going to try to move student up a bit, see how well that works. Okay, and then let's just grab a relationship. Put the many side on attendance. So we're going to put the many side on attendance. Let's just do that. Okay, there's the many side on attendance, but it hasn't really rendered that well, so I'm going to do an undo. Don't know what's going on here. So that looks like the one side. Okay, so perhaps I didn't undo it. And then let's pull this one side. Let's go up and try to pull it over and put it onto student. And this is worrisome because it doesn't seem to be behaving. So let's pull the one side over here and connect it to student. Okay. And then we just move that up there. Okay, and we've got the one and the many at the wrong ends now. So the way that we usually resolve that is to, first of all, we're going to move this thing to where it should be. And then we have the endpoints with the wrong cardinality indicators. So I'm going to select the relationship and I'm going to right click, and the begin symbol currently says 0 or more. So I'm going to flip that to 1 and only 1. And now I'm going to set the other one, the end symbol. It currently says 1 and only 1. I'm going to flip that to 0 or more. And so now I've got the many side up against attendance. And if I go all the way to student, I find that it's not connected to student anymore. That's wonderful. So let's see what we can do. See if we can get this to connect to student. That looks a little better. Okay, so it's not perfect. Oh, now it's done that again. So it seems to do either one or the other, but not both. My. Isn't that interesting? Okay. All right, that looks a little better. So again, we have resolved a many-to-many by adding an associative table. Oh, and we didn't put in the proper names for the keys yet. So first one, student ID, then semester ID, then course number, then section ID, then meeting date. And that's going to do it. Okay? So it's all key. It's all plumbing. It's not there to hold any data that's associated with the relationship. It's just there to implement the relationship. Okay, so now we've come to the end. We were working on the step to resolve many-to-many relationships, and now we've done that for 2 many-to-many relationships. We have created associative tables or intersection tables for both of them, and now we're all set on that score. So we're going to say bye until the next part.